In the last video, we took a look at all the basic information necessary to be able to work with quadratic functions. And in this video, we're actually going to utilize that information. And so we're going to go through and given the functional representation of a quadratic function, we're going to find the coordinates of the vertex. We're going to find if the vertex is concave up or concave down. And then also, we're going to determine if the vertex is a maximum or minimum of the graph of the parabola. We're going to also find the axis of symmetry. We're going to find the domain and range of the function. And then finally, this might be the most painful part, is finding the intercepts. So recall that a quadratic function is of the form f of x equals a x minus h plus k. And then we have a square in there. So that's going to be x minus h quantity square plus k. And so in this case, we can clearly see that h is going to be 3 and k is going to be 4 in this quadratic function. So for the very first part, it looks like that the vertex is going to occur at the point 3, 4. Nice and easy. Okay. If the parabola is concave up or concave down. So we can clearly see that a is going to be 2. And 2 is greater than 0. So that means it's going to be concave up. Okay, so since a is equal to 2, which is greater than 0, we're going to say that it is concave up. And also, since a is 2, which is greater than 0, we have to determine that this is going to be a minimum of the function. The other component that's actually really easy is we're going to find the axis of symmetry. All right, and so the axis of symmetry for this is going to be at the line x equals 3. Okay, so since h is equal to 3, so since h is equal to 3, that implies that the axis occurs at x equals 3. All right, and we're going to graph this, by the way. So as we're going along, we know what the vertex is. We know it's going to be concave up. So we know it's going to have like this sort of shape to it. Okay, this would be the minimum of that function. Okay, and eventually we will get a better graph for this. Now, the domain of a quadratic function is really easy. It's always all real numbers. Okay, so the domain of all quadratics is going to be from negative infinity to positive infinity. Okay, but the range is not all real numbers all the time. Okay, so for our range, what we're going to do is we're just going to look at the vertex. All right, and if I were to just plot a really basic graph of this, okay, so and I have no idea if this is exactly what it looks like, but remember we have the point 3, 4 as the vertex. It's right here, and it will probably look something like this because it's concave up. Just basically sketching that graph, we know that the lowest y value is at 4. All right, so y would go from 4, and then notice it just keeps going up forever. So the range for this would be 4 to infinity. All right, and notice that it keeps going to the left for the domain and to the right for the domain. So that kind of justifies what we noticed before, is that the domain is all real numbers. All right, so the range for this specific quadratic is going to be y is in 4 to infinity. All right, and we're going to see in other examples that it might be from negative infinity up to a specific value. All right, now the last thing that we have to do is we have to find the intercepts of the function. All right, in other words, where does it cross the x and the y axis? All right, so that's probably going to be the toughest part of this particular example, although it's not too bad. Okay, so let's start with the y-intercept. Those are usually a little bit easier. And the y-intercept is found when x is equal to 0, or in other words, we're finding f at 0. All right, these are the easier ones. Okay, so all I'm going to do is just substitute 0 back in for x. So f at 0 is going to be equal to 2 times 0 minus 3 squared plus 4. And if we evaluate that, that's going to be 2 times negative 3 squared plus 4, which is going to turn into 2 times 9 plus 4. We know 2 times 9 is going to be 18. And so that just works out to be 22. All right, so that means that the y-intercept, this is 18, this occurs at the point 0, 22 is the intercept, or we just say the y-intercept is equal to 22. All right, so if we were to go down here on this graph, it would be way, way, way up here. I'm going to erase this in a second, but the intercept would be like somewhere way up here, okay, if I were to graph it, okay, but I'm not going to. All right, now for the x-intercepts, what we're going to do is we're going to set y equal to 0. Okay, that's a little bit tougher for us. Okay, so let me erase this. And so for the x-intercepts, we're going to set y equal to 0, or in other words, that means that f of x is going to be equal to 0. And so we're going to get 0 is equal to 2 quantity x minus 3 squared plus 4. All right. Now, to solve this equation, okay, we certainly don't want to subtract 4 from both sides, okay? Remember, to solve any quadratic, we have to set it equal to 0, okay, which it already is. And then what we're going to have to do is we're going to have to FOIL this out, okay? So we want to try to identify and put it in the form ax squared plus bx plus c, okay? So we want it in the form y equals ax squared plus bx plus c. So let's put it in that form. That should be an x in English. Sorry about that. All right. So if I FOIL this out, we get 0 equals 2 parentheses x minus 3 plus 4. And 0 is going to be 2 quantity. I'm going to FOIL this out. So x squared minus 3x, and then minus another 3x, and then plus 9 plus 4. And then we distribute the 2. That's 2x squared. Notice that this becomes negative 6x, right? And then 6x times 2 is a negative 12x. And then we have 2 times 9, which is 18. 18 plus 4 is going to give us a 22. All right, so that's the expanded version, okay? Now, let's see if we can factor this, all right? It might be factorable. It might not be, okay? We don't know yet, but let's give it a try and see if we can factor it. And if it's not factorable, then what we're going to do is we're going to use the quadratic formula, okay? So the first thing I'm going to do is I'm going to factor a 2 out of there. And if I factor a 2, that gives me x squared minus 6x plus 11, all right? And unfortunately for us, there's not two numbers that are going to multiply to 11 that add up to negative 6. The only factors 11 are 11 and 1, and that's not going to be factorable. But it's not a complete waste of time, because now what we could do is we could divide both sides by 2, right? And this is a trick you guys can always use when you're solving a quadratic. You could divide by 2, and that means we're left with this equation, 0 equals x squared minus 6x plus 11, right? Now what we can do is we can use the quadratic formula to be able to solve for the x-intercepts for this. And remember, our quadratic formula, x equals the opposite of b, plus or minus the square root of b squared minus 4ac divided by 2a. And clearly we can see in this part right here that a is 1, b is negative 6, and c is 11. All right, so let's get to it. It's not going to give us a nice number, all right, but that's okay. We can still figure out what the intercepts are going to be. All right, so x is going to be equal to the opposite of negative 6, so negative b, plus or minus the square root of opposite of 6 squared, plus or minus 4 times 1, which is a, times 11. I'm sorry, just minus, not plus or minus, excuse me. And then we're going to divide that by 2 times 1. Right? Now, if we simplify this, x is going to be positive 6 plus or minus the square root of 36 minus 44 divided by 2. And then here's where we can kind of stop almost, because if we simplify that, that's going to give us 6 plus or minus the square root of negative 8 divided by 2. And notice that we have the square root of negative 8. as soon as we get a square root of a negative number, we stop, okay? Because what this means is that it's not real, okay? And so what this means is that there are no x-intercepts, okay? So it's not real because we have a negative number under the square root, okay? And that means that there are no x-intercepts. All right. Now, just to finish this off, let's graph it in our graphing calculator and see if it kind of matches up to everything that we've gotten so far. Okay, so remember, we said the vertex was at 3, 4. We said the axis of symmetry was x equals 3. We see it's concave up, there's a minimum. The range is from 4 to infinity, domains from negative infinity to infinity, and then we have this 0, 22 as our intercept. Okay, so let's go ahead and plot it. So remember, we had our function, and I'm just going to use y. We had two quantity, x minus 3 squared plus 4, right? And so, and then I'm also going to plot the axis of symmetry, x equals 3, all right, just so that way you can see it. Now, check this out. Here's our vertex, okay, right here at the point 2, 3. Okay, so if I zoom in a little bit, here, I'm sorry, 3, 4. So we go right 3, up 4. I'm going to go all the way up to 22 on this graph. All right, and right here is our intercept, 0, 22. In fact, if I plotted that, so I can plot the point 0, 22, right there it is. Okay, so that's going to be our y-intercept. And also, let me plot the vertex just because I can. All right, so I'm going to go back down. Right, so that's pretty cool right there. Notice it never crosses the x-axis, okay? So that means there's no intercepts, which we already said. And then finally, we notice that if I was to keep going up, the x value is going to keep getting bigger and bigger on both and smaller on both sides. So it looks like, yes, that we've dissected this parabola correctly, right? So we have two more of these examples, and in both of those, I'm going to illustrate how to go through and take a look at some maybe a little bit more different of the two types of parabolas in our subsequent videos.